Hey everyone, I am Ms. Hu, your physics teacher. In this video, we're going to go through an overview of Unit 1, Motion, Forces and Energy, which is part of the IGCSE Physics syllabus for the 2023 to 2025 cohorts. Now, this video is only going to be an overview, which means that it's designed more for students who have already learned this unit and just need a reminder or a refresher of what they need to know to answer the questions in the upcoming examinations. If you are learning these topics for the first time, this is not the video for you. Please go and watch my videos on those respective topics instead. So because this is an overview to prepare students for their examinations, there will be a lot of references to the syllabus guide just to make sure that we have covered everything. Alright, let's get started. So first of all, we will start with the very basics, which is on physical quantities. Make sure that you know how to describe the use of rulers as well as a measuring cylinder to find length or volume. So we're not going to go through how to use this. This is just to remind you, you need to know how to use the ruler and measuring cylinder. You'd also need to be able to describe how to measure time intervals using clocks and digital timers. You would also need to know how to determine the average value for a small distance and for a short interval of time. So, for example, to measure very small distances, like measuring the diameter of a wire. Now, you can't measure the diameter of a wire directly with a ruler, but what you can do is get a wire and loop it around a pencil and place those wires next to each other and then measure the length of that coil, divide it by the number of loops, and then you can get the diameter of the wire. So that's how you get the average value for such a small distance. Using the same idea, you can also measure the short interval time, for example, the period of oscillation. So if you have done the pendulum experiment, you should of course know that it is very difficult to measure just one period of oscillation directly with a stopwatch, especially if the time is very short, for a very short length of pendulum. So instead, how can we get that measurement? We take the time for many complete oscillations, for example 10 or 15 or 20, and then to get the period of oscillation, what you do is you take the total time divided by the number of complete oscillations. That's how you can get the period of oscillation. You should also know about scalar and vector quantities. You need to remember that scalar quantities only have magnitude, while vector has both direction and magnitude. Now when it comes to science, there are plenty of scalar and vector quantities in there. The list is actually endless, but for IGCSE, the ones that you must know for certain are these two lists. Scalar quantities include distance, speed, time, mass, energy, and temperature, while the vectors are force, weight, velocity, acceleration, momentum, electric field strength, and gravitational field strength. Now, a reminder, there are many more scalar and vector quantities that exist in both these lists, but for IGCSE, it is sufficient to just focus on the quantities in these two lists. Now, let's go into vector diagrams. So you should be able to determine by calculation or by graphically drawing it out the resultant of two vectors at right angles, and you only need to focus on forces or velocities. So there are plenty of other vectors, and yes, even other vectors may require you to get the resultant of the two vectors at right angles, but for IG, only forces and velocities. So just a quick overview on how to solve vector diagrams. So let's say we've got these two arrows here that represent the vectors. So just for the explanation of the example, say that they are forces. So I'm going to label this as F1 and F2. So to solve the resultant force in this case, if you have the two arrows acting right angle to each other like this, what you need to do is to just complete the parallelogram, which in this case is the rectangle. So just draw with dotted lines the opposite sides with the same length and just use logic. So if you have an object where there are two forces pulling this way, the object is going to move in between like this. So which means that the resultant force is in between the two forces. Therefore, the resultant force, which I'm going to draw here in blue, is from this corner to that corner. So I'm going to label this as the resultant. So whether you're solving this for velocities or forces, this is how you solve it. So if you were drawing this graphically, you would have to draw this to scale. That means the force lines of F1 and F2 must be drawn to scale. For example, if the scale was 1 cm to 1 Newton, that means you would measure out with your ruler the lengths of those forces using that scale. Example, if it's 10 Newton, you measure out 10 cm. If it's 3 Newton, you measure out 3 cm. To get the value of the resultant, then just use your ruler, measure this line, and then use the scale to get the actual value of that particular vector. Now, if you wanted to calculate this, then you don't have to draw it out to scale. You can see from this diagram, the resultant force forms a triangle. So what you do is you just use Pythagoras theorem to solve the value of the resultant force. If you can't remember how to solve all this, please watch my video about vector diagrams. Before we move on, I'm just going to show you there's another method to solve the vector diagram. So instead of completing the rectangle this way, you can also draw a triangle. So for example, if I draw F2 this way, so I'm just being a bit lazy here, I'm not going to draw using the arrows of this whiteboard. Just going to draw a freehand pencil, F1, like so. So if you want to solve the vector diagrams using a triangle, instead of having the two arrows start from the same point, you can have the arrows one after the other. So you imagine as if the object is being pulled first by F2 and then pulled again by F1. So you have a start and an end. The resultant force in this case would be from start to end, like so. So if you were solving this graphically, then same thing, you would measure out the length of these arrows based on the scale provided, and to get the answer for the resultant, measure the length and use the scale to get the actual value. If you were calculating it out, again, you see this is a right angle triangle, use Pythagoras theorem to solve the resultant force. Let's move on. Now, for linear motion, you must be able to solve the questions by calculations. And of course, you have to remember the formula. And you must, of course, know the speed formula. So speed is distance over time. Or using symbols, v equals s over t, where v is speed, s is distance, and t is time. So speed is scalar, while velocity is a vector. That's why you need to know that velocity is speed in a given direction. To calculate the average speed, it's still the same formula, it's still distance over time, but to calculate the average speed, you take the total distance traveled divided by the total time taken. So a lot of students always think that, oh, in math, when you calculate average, you plus, divide by the number. But when you're talking about speed, because the speed of an object could constantly be changing. So if a car was moving, it could be moving fast, moving slow, faster and slower. So if this was the speed graph, you can't be adding all the speeds, you know, and then divide it by, okay, how many different speeds were there? That doesn't make any sense because it's motion, right? It's moving. So that's why when you want to calculate average speed, it just makes sense that you take the total distance divided by the total time. So the object could be moving, you know, fast, slow, stop for a while, and then move again. Doesn't matter. You just take what's the total distance between the start and stop and the time taken between the start and stop. You should also know that acceleration is the change in velocity per unit time. And in symbols, the formula is A equals V over T, or as very commonly written, or as more commonly written, A equals V minus U over T, where V is the final velocity, U is the initial velocity, and T is the time taken for the initial velocity to become the final velocity. Next, you need to know about motion graphs as well, where you need to be able to sketch, plot, and interpret distance, time, and speed time graphs. So again, in this video, we're just going to go through an overview. So if you don't really remember much about motion graphs, please watch my video on motion graphs. Generally, you need to be able to sketch, plot, and interpret distance time and speed time graphs, as well as determine qualitatively from the data or the shape of the distance time or speed time graphs when the object is at rest, moving with constant speed, accelerating or decelerating. If you were given a distance time graph, you need to be able to calculate the speed. Now, how you remember that the speed is the gradient? Say, for example, we have a distance time graph. So you can see that in this case, the object is moving away, so it's a positive gradient. At this point, the distance doesn't change, which means that the object is stationary, and then now it's moving backwards towards its original starting point. Mathematically, you should remember that gradient is a change in y over the change in x. In this graph, y is the distance, so it's a change in distance, and x is time, specifically this one, change in time. So here the gradient of the distance time graph is a change in distance over the change in time. So if you recall what we've just looked at in the previous slide, speed is distance over time. That's why the gradient is equal to the speed. And if you look at the graph, that makes sense, right? Because in the first part here, the object is moving. So because it's moving, there's speed. And because the graph is linear, the speed is constant. At this point, distance doesn't change, so the object isn't moving. Here, gradient is 0, therefore speed is 0. Now the object is moving backwards towards its original starting point. That means that the direction it's moving in is negative, so that's why moving backwards. So the good news is you only need to be able to calculate speed from a straight line graph. You don't have to worry about curve graphs and all that, not for IGCSE. In addition to distance time graphs, you also need to know how to interpret speed time graphs. So what you need to know is to be able to calculate the area under the speed time graph to determine the distance. And this is for motion with constant speed or constant acceleration, which in this case actually refers to straight line graphs as well. You also need to be able to determine whether object is moving with constant acceleration or changing acceleration. You need to be able to calculate the acceleration from the gradient of a speed time graph and know that deceleration is a negative acceleration when using this in calculations. So this is a straight line graph. And because it's a straight line, that means the change in speed is at a constant rate. Therefore, this is constant acceleration. If you have a graph that looks like this, where it's a curved graph, you can see that the gradient is increasing. And what this tells us is that the acceleration is increasing. Whereas if you have a graph like this, curved graph, but the gradient is decreasing, then the acceleration is decreasing. Now all of these are still positive accelerations. In order to get negative acceleration, the gradient of the graph has to be negative. So for example, if you get a graph like this. So here in this yellow graph, the gradient is negative, therefore it is moving with negative acceleration. So negative acceleration means when you do the calculation, you have to add a negative symbol in that value and use that accordingly. Why is it that gradient is acceleration? Because similar to the example just now, if we know that the gradient is a change in y over change in x, the change in y is the speed, whereas x is time. If you can remember the formula, the change in speed over change in time, similar to change in velocity over change in time, is actually equal to acceleration. So that's why the gradient is equivalent to the acceleration for a speed time graph. For area under the graph though, for example, if we took the straight line, you get a triangle, it will be half time space times height, which is half speed time. Generally, whether it is a triangle or a parallelogram or a curve, you can see you calculate the speed times time, and then you make adjustments depending on the shape of that polygon. So let's say in this case, I'm just going to put the general formula, speed times time. you should be able to see that if you modify the speed, distance, time formula, so if we were to take the general speed formula, which is distance divided by time, if you rearrange the formula making distance the subject, you get distance as speed times time. That's why area under the graph is equal to the distance. So this is just to remind you how you can work it out if you forgot what the relationships are between gradient acceleration, area, and distance. Okay. Next, let's look at free fall and gravitational acceleration. You must of course know that the acceleration of free fall for an object near the surface of the Earth is approximately constant at a value of 9.8 meters per second squared. And the good news is that this value is given on the cover of your theory paper, so even if you forgot for some reason, just refer to the value of g, which will be written on the front cover of your exam sheet. You also need to be able to describe the motion of objects falling in a uniform gravitational field with and without air or liquid resistance, and you must also know how to refer to the terminal velocity. So for this particular kind of question, you do need to recognize the graph and you need to identify what's happening to the falling object at different points on the graph. The kind of questions that have appeared in past year questions could include the entirety of this graph, or the first part of the graph, or the second part of the graph, or maybe even ask you to draw the graph. So the shape of the graph is very fixed. You don't change the shape of the graph. You need to know the shape and know what's happening at each area and point on the graph. This is rather a long topic as well, so I'm not going to go through this in detail. If you'd like to revise this topic in more detail, please watch my video where I explain this graph in detail as well as with references to the forces. Because yes, you also need to know how to describe how the forces acting on the skydiver affects the acceleration and velocity of the skydiver. So I'm just going to explain very briefly for now. You will also be required to state the relationship between the acceleration and the net forces acting on the skydiver. So for this, you need to recall that when it comes to the relationship, you just need to use the F equals ma formula and look at the relationship between the net force and the acceleration. So the first part of the graph is when the skydiver first jumps out of whatever he's at, whether it's off a hot air balloon or a plane, and the parachute is not open. So the skydiver first is falling with free fall at 9.8 meters per second squared. So at this point, there is zero or very little air resistance. But as the skydiver falls, the increase in speed increases the air resistance acting on the skydiver, which then changes the net force acting on the skydiver. As a result, because the weight is equal but the air resistance is increasing, the net force decreases, which causes the acceleration to decrease until the weight and the air resistance are equal. That means the net force is zero, therefore acceleration is zero. When acceleration is zero, the velocity is constant. So at this point, where there's constant velocity, this is the terminal velocity of the skydiver while the parachute is still not open. So that's why you get terminal velocity over here. Obviously, in order to not fall splat like a tomato hitting the floor, to make sure that the skydiver still lives, open parachute. Ba-tum. So when the parachute is open, that happens at this point in the motion, right here. So what happens is the moment the parachute opens, there's a huge amount of air resistance, very high air resistance. The air resistance is now greater than the weight. So what happens here is now when the net force is negative, acceleration is also negative. So that's why you find the velocity decreases, showing negative acceleration. The air resistance would then decrease until it is equal to the weight. So that's why you find that the negative acceleration, the magnitude decreases until we get a net force of 0, where at this point, the air resistance is equal to the weight. So at this point, the skydiver is falling with terminal velocity, but with the parachute open, until finally reach the ground safely. So like I said, if you cannot remember this and you want to go through more detail, watch my video about the skydiver and this graph. Let's go on to mass and weight. So this should not be a difficult concept because you should already have known the difference between mass and weight since primary school. But we'll just go through what you need to know. So you need to know that mass is a measure of the quantity of matter in an object at rest relative to the observer. You got to state that weight is a gravitational force on an object that has mass. You need to know how to calculate the gravitational field strength, which is this formula where G equals W over M. And that the value of G is equivalent to the acceleration of free fall, 9.8. You need to know that weights and masses may be compared using a balance, and you need to be able to describe and use the concept of weight as the effect of a gravitational field on a mass. You also need to know about density, and of course you must know the density formula, which is mass per unit volume. In this case, remember, this is rho, not P. Rho is a Greek letter taken from the Greek alphabet that is normally used to represent density. You also need to be able to determine the densities of the liquid, regularly shaped solid, and an irregularly shaped solid which sinks in a liquid using appropriate calculations. So normally in this case, the question will give you various data. You need to know what to minus, what to take and multiply and divide. So it's a matter of just reading the question carefully and using the data accordingly. You also need to be able to determine whether object floats or sinks based on the density data, as well as how the liquids are able to float or sink compared to one another. Next, you need to know about the spring. So you need to know that forces could produce the change in the size and shape of an object. And from a spring experiment, you need to be able to sketch, plot, and interpret the load extension graphs. For an elastic solid, in this case, normally would be the spring, and you need to be able to describe the associated experimental procedures. So if you can't remember that, please watch my video about springs. Now you of course also need to be able to define the spring constant, where the formula is given here as K equals F over X, where K is the spring constant, F is the force applied, and X is the extension. So spring extension is the change in the spring length, not the entirety of the new spring length. So for example, if this is a spring, and if we hang an object on it, of course the spring is going to extend or increase in length. The extension is that change in length. So this is extension. So not the entire spring length, not the original spring length, the difference in the spring length from the original to the new length. You also need to know the term limit of proportionality and what it means and how to identify it on the graph. Now, if you were to do the experiment and if you keep overloading the spring would eventually become deformed where it's not able to return to its original shape and size. You'll find that the spring no longer follows the original relationship, which is a directly proportional relationship. On the graph, you'll see it as straight line initially, then when the spring has been overloaded and has deformed, the graph will curve. The limit of proportionality is the maximum point where the graph is linear. It's very logical because proportional here means that the relationship is proportional. That means the graph is a straight line. So if the graph is no longer straight, that means it has gone beyond the limit of proportionality. So if you were asked to determine where the limit of proportionality is, that's the maximum point of linearity. So I'm going to write that here. This is the maximum point of linearity. I'll just say linear graph. So linear graph. The term elastic limit is a different meaning. It's actually the maximum point where the spring could return to its original shape and size. But you don't learn about that in IGCSE, so you can skip that altogether. That one will probably be covered in A levels. From the graph, if it's a force extension graph, the slope would give us a spring constant. Now this is specifically for a load extension graph. If it was the other way, where the extension is on the y-axis and the load or force is on the x-axis, then of course that would be the inverse. But as you can see here in the syllabus guide, it does say load extension. So when they say load extension, that means load is on the y-axis, extension is on the x-axis. Therefore, the slope, or rather the gradient, will give us a spring constant. All right, let's move on. You also need to know about resultant forces. You need to know how to calculate the resultant of two or more forces acting along the same straight line. So for example, the forces could be in the same direction, or they could be in opposite directions. Whichever the case, they're in the same straight line. So if they're in the same direction, you add them together. If there's any in the opposite direction, you minus. You also need to state that the resultant force may change the velocity of an object by changing its direction of motion or its speed. You need to be able to describe solid friction as the force between two surfaces that may impede motion and produce heating. You also need to know that friction can act on an object that's moving through a liquid or through a gas, and these are known as drag. An example of drag would be air resistance. And of course, you also need to know how to use this formula, F equals ma, to show that the force and acceleration are in the same direction. You need to be aware about inertia, where an object either remains at rest or continue moving in a straight line at a constant speed unless acted upon by a resultant force. And here's just a funny meme for you to remember inertia. And inertia is actually explained using Newton's first law of motion. So there's not much you really need to know about this. You just need to know about the property of an object in this way. Now, for circular motion, you need to be able to identify what happens when an object is moving in a circular path. Now, it does say here the force perpendicular to its motion. This is actually known as centripetal force, and you must know that in a circular motion, the resultant force is the centripetal force. The centripetal force is a force that acts towards the center of the circular path. So, for example, if you have a satellite orbiting a planet, there is a resultant force. The resultant force is known as the centripetal force, and this acts towards the center of the path. In this case, the centripetal force is equal to the gravitational force acting upon the satellite by the planet Earth. You need to be aware of the factors that affect the centripetal force. The force increases when the speed increases, or radius decreases, or an increased mass, as written here. You can actually make a reference to the factors by using this formula, F equals mv squared over r, where F is the centripetal force, m is the mass of the moving object, v is the speed of that object, and r is the radius of that circular path. You don't actually need to know it, as mentioned here, it's not required, so you don't need to memorize this formula, you don't need to know how to use this formula, you don't need to know how to use this equation to solve questions, but I find that it's easy to remember the factors if we know the formula. If you can't remember the formula, then you memorize ABC instead. Let's move on to moments. So you need to know that moment is actually the measure of its turning effect of a force. And the definition of moment, you can use a formula in this case, which is that moment is force times perpendicular distance from the pivot. So you need to know how to define it as well as to use this equation to solve calculation questions. Now you also need to be able to apply the principle of moments to situations with one force on each side, including a balancing of a beam. So what's the principle of moments? It's this. Clockwise moment equals to anti-clockwise moment. So if we were to look at the diagram on the top here, we have two objects placed on either side of a pivot. So we have the weight it's pulling down. And because the yellow triangle here is the pivot, you'll find that the box will create an anti-clockwise moment while the bucket will create a clockwise moment. If the beam was balanced, then the anti-clockwise moment by the box must be equal to the clockwise moment caused by the bucket. So here you'd calculate the force times its distance. So I'm going to label this F1 and D1. And for the bucket, if this is D2 and F2, F1 D1 must be equal to F2 D2. Now this would only work if the pivot was directly at the center of this uniform beam, because the beam also has weight. So if the pivot was directly under the center of mass of that beam, you can ignore the weight of the beam. However, if the pivot was at the side, then you can't. You must remember that the beam also has weight, which means that if the pivot was not under that center of mass, if it's to the side, for example in this second diagram, then the beam also applies a moment around the pivot. So you would need to take into account the moment caused by the beam. So now we have three moments to consider. We have the moment from the bucket, we have the moment from the beam, and there's also a moment from the rope. So let's say this rope is now supporting this beam, and because it's pulling upwards, the force is acting upwards. So you can see here, I'm going to label this as W1, going to label this as F2, we've got D2 and D1. And then let's put this as T, and let's label this as D3. So you have here an anti-clockwise moment, a clockwise moment, an anti-clockwise moment. That means that you have F2 times D2 plus the tension times D3, because anti-clockwise moment plus anti-clockwise moment equals to the clockwise moment. So that's how you would solve this kind of question with multiple moments. Alright, so let's move on now. You need to know that when we say an object is in equilibrium, there's no resultant force and no resultant moment. So that means the forces are balanced, there is zero net force, and there's no rotation, then the resultant moment is zero. You also need to be able to apply the principle of moments to other situations, including those with more than one force on each side of the pivot, as shown over here in the second diagram. And you need to be able to describe an experiment to demonstrate there is no resultant moment on an object in equilibrium. So that one is under the moment experiment. Right, next, for center of gravity, you need to be able to state the meaning of center of gravity, which is the point where all the weight of the object seems to act upon. You need to be able to describe the experiment to determine the center of gravity of an irregularly shaped plane lamina. For the experiment, remember that whether it's a triangle or it's an irregularly shaped card, you want to hang the card from 3 different points on that irregular shape, hang the plumb line in front, then mark the position on that card, and then draw the lines in such a way so that you'll find the center of mass, which is the intersection point of all those lines. So I do have a video which explains and demonstrates this experiment. So if you don't remember the experiment, please watch that video. Next, you also need to be able to describe qualitatively the effect of the position of the center of gravity on the stability of simple objects. So remember that the center of mass depends on the area where the mass is focused at. I also have a video which does show a simple activity and detailed explanation about the center of gravity. Do watch that video. For now, I'm just going to do a very quick overview. So if you have an object where the mass is uniformly distributed, the center of mass is in the middle. Whereas if you have a situation like this, where the mass is more focused on the bottom, your center of mass is usually in the region where most of the mass is at. If there's a little bit more water in the bottle, in this case, center of mass could be higher. Now remember that for stability, the line of gravity or the weight line has to be within the base area for it to be considered stable and will not topple over. If the weight line is outside this base area, then the object will topple and fall down. Next, momentum. Momentum is mass times velocity, so that's the formula that you need to recall and must know how to use. In symbol form, it's just P equals mv, where P is momentum, m is mass, and v is velocity. You must also know that impulse is force times time. And it's not written here, but you also should remember that impulse is also known as the change of momentum, because sometimes in the past year questions they don't ask students to calculate impulse. They'll say calculate the change of momentum. So change of momentum quite simply is mv minus mu, where m is the mass, v is the final velocity, and u is the initial velocity. So it's quite easy to calculate change of momentum if you just look at the words, change in momentum, right, between the final and initial. But what you should be aware of is that impulse is actually change of momentum. In addition, you need to know that resultant force is a change in momentum per unit time. So right here, short form of F equals mv minus mu over t. And if you can see the relationship between impulse and force, because impulse is force times time, therefore force is impulse divided by time. So these are the few equations that you need to know that uses momentum. Now, in addition, you also need to know how to apply the principle of conservation of momentum to solve simple problems in one dimension. So why one dimension is mentioned here? Because in the real world, collisions can happen, in all directions. So rather than look at all the different directions they're coming in IGCSE, we just solve the problems that are all in a straight line. Much easier. The principle of the conservation of momentum states that the total momentum before collision is equal to the total momentum after collision. So if we look at two objects that will collide with each other, and let's say they're moving in whichever direction, could be moving opposite, same direction, whatever, you have two objects here with their own respective momentums. So first object, m1, second object, m2, the mass does not change. The initial velocities could be different. So this could be u1 and u2. So I'm going to put here m1 u1, m2 u2. The final velocities could change. So let's put it as v1 and v2. So the conservation of momentum states that the total momentum before collision is equal to the total momentum after collision. So this is the general formula for the principle of conservation of momentum. For elastic collisions, the objects move separately after collision, whether they're moving, opposite direction, same direction, whichever. Okay, the formula that we use is actually this direct formula, which is m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. Another thing that you must remember about elastic collisions is that the kinetic energy should be conserved before and after collision. I say should be because that's only true for true elastic collisions. So there are some collisions where the kinetic energy is not conserved. Those are not considered true elastic. But anyway, you don't have to worry about that for IGCSE. Now for inelastic collisions, the objects stick together after colliding, which means that they have the same final velocity. That means v1 and v2 are equal. Because v1 and v2 are equal, we can factorize it, or you can think of it as these two objects have combined together to form one big object. Therefore, we will modify this formula slightly to combine the two masses, so as if they're combined into one big object and they both move the same final velocity of v. For explosions, they're a little bit different, and a typical example of a situation using explosion would be the firing of a bullet from a gun, because there's an explosion that makes the bullet and gun separate. So for explosions, the initial velocity of both objects is 0. So they're both not moving. An explosion occurs which causes the bullet to move forward and the gun to recoil backward. Because the initial velocities are 0, that means u1 and u2 are both 0. So anything times 0 is 0. 0 plus 0 is 0. So the left-hand side of this equation for an explosion would be 0, giving us 0 equals m1 v1 plus m2 v2. So if we rewrite this formula, you could get m1 v1 equals to negative m2 v2. So this is the equation we can use for explosion. The negative here indicates that both objects are moving in opposite directions. Now, if you can't remember all these three different formulas, you just need to remember this formula and learn how to modify this to suit the situation in the question. Okay, let's move on to energy. Now, for energy, you need to be able to state that energy may be stored as kinetic, gravitational potential, chemical, elastic, nuclear, electrostatic, and internal energy. You also need to be able to describe how energy is transferred between stars during events and processes. That means you need to be able to state how the energy is changed from one form to another form. So for example, mechanical work done, electric currents, heating, electromagnetic sound, and other waves. You need to know the principle of the conservation of energy, where energy cannot be created or destroyed. It can only transform. And you apply this principle to simple examples, including the interpretation of simple flow diagrams. In addition, you should also know the kinetic energy formula, which is half mv squared, and the gravitational potential energy formula, which is mgh. And you also need to know how to use this formula in calculations involving the principle of conservation of energy, and also to interpret Sankey diagrams. Here are some very simple examples. So for example, in a waterfall, because water is falling, at the top, water has potential energy, and this energy is converted to kinetic energy as it falls. So at the top here, we have, I'm going to write it short form, we have gravitational potential energy, or GPE for short, and as it falls, it loses gravitational energy and gains kinetic energy. So the water has the most kinetic energy just before it reaches the bottom. So when it hits the bottom, the energy could be converted into sound as well as thermal energy. And of course, there may be some remnant kinetic energy at the bottom. So gravitational potential energy was converted to kinetic energy, which could be converted to sound and thermal and kinetic energy. Similarly, when you drop a stone, at the top it has gravitational potential energy. As it falls, it will be converted to kinetic energy, and when it strikes the ground, if it just comes to a stop, it could be converted to sound and thermal energy. If you were throwing an object at the bottom, that's when it has the most kinetic energy, and this would then be converted to gravitational potential energy. So if we were to do calculations, most calculations would involve the conversion between the gravitational and kinetic. It's possible for sound and thermal as well, so it does depend on the question, but for now I'm just going to talk about examples of the conversion between gravitational and kinetic. So if we were required to do calculations involving these changes in energy, so for example, if in this diagram we were asked to determine the maximum height which the ball is thrown, we can use the understanding of conservation of energy to solve this question, where we assume all the kinetic energy from the start was converted into gravitational energy. Depending on what values were given in the question, but I'm just going to apply the formula here. Half mv squared, which is the kinetic energy formula, would be equal to mgh, which is the gravitational energy formula. So this is an example of how we can use the formula as well as the understanding of the principle of conservation of energy to solve questions. Okay, let's move on. For work, you must understand that mechanical or electrical work is equal to the energy transferred, and the formula is force times displacement, where force is the force applied and displacement is how much distance the object has been moved due to that force applied. For energy resources, you are required to be able to describe and state all the following. You must be able to describe how useful energy may be obtained or electrical power generated from chemical energy stored in fossil fuels, chemical energy stored in biofuels, water, such as the energy stored in waves, tides, and the water behind hydroelectric dams, geothermal resources, nuclear fuel, light from the sun to generate electrical power through solar cells, and infrared and other electromagnetic waves from the sun to heat water in solar panels and be the source of wind energy. And you also need to include references to a boiler, turbine, and generator where they are used. So it does depend on the question. You need to describe advantages and disadvantages of each method in terms of renewability, availability, reliability, scale, and environmental impact. You need to know the radiation from the sun is the main source of energy for all our energy resources except geothermal, nuclear, and tidal. So this is quite a common question. They normally do ask which ones are not from the sources of the sun. So remember TNG, which is like touch and go, right? Tidal, nuclear, geothermal, TNG. Sometimes they do ask the flip side, which energy sources are from the sun. So your resources should not include any of these three. Oh, here's a beam, by the way, for you to laugh at. You also need to know that energy released from the sun is due to nuclear fusion, and you have to be aware that research is being carried out on how nuclear fusion can be used to produce electrical energy on a large scale. So for all of this, you do need to do a little bit of reading, but more importantly, you need to be able to answer the questions based on all these. And by doing past year questions, you should normally be able to see what they're asking and how to answer those questions. For efficiency, you need to be able to explain the concept of energy transfer in terms of efficiency. And you need to know the efficiency formula. They can be calculated based on energy or power. Generally, it's just the useful output over the total input, whether it's energy or power. So as you can see here, efficiency can be calculated as the useful energy output over total energy input times 100%, or useful power output over total power input times 100%. The efficiency is normally expressed in percentage. For power, you need to be aware that there are two formulas for power. You can calculate it as work done over time or energy over time. So both are accepted because by now you should know that work is actually a type of energy. They're both expressed in joules. And of course, power is expressed in watts. And as for pressure, you need to know the formula for pressure, which is force over area, or with the symbol form, P equals F over A. And you need to be aware of how pressure varies with force and area. So for example, if an object like this, the force is the weight of the object, and the area is the area of that surface that's in contact with what it's resting on. So if you place the object on its largest area, it will apply the lowest pressure. Whereas if you stand it on its side with the smallest area, then the pressure would be the highest. So for example, also if you have a cone like this, if you place the object on its smallest area, this will apply the highest pressure. So that's why when you hammer a nail, you would hammer the nail in at the sharpest point. If you were to invert the cone where it's resting on its largest area, it will have the smallest pressure. You also need to know about liquid pressure. You have to be aware that pressure beneath the surface of a liquid changes with its depth and density. And you must know the formula, which is rho GH, where rho is the density of the liquid, g is the gravitational acceleration, 9.8 meters per second squared, and h is the depth below the surface of the liquid. So just to remind you, depending on how the question is phrased, liquid pressure is calculated with the formula of rho GH. So for example, if we needed to calculate the pressure acting on this fish, it would be this h. So remember, h is depth, not height. Because some students think, oh, h represents height. So some students may mistakenly take this value of h because to them, h is from the surface up. So this is wrong. You don't take that value. You take h1 because pressure of a liquid is due to the weight of the liquid acting on that object. So the correct one to take would be h1. Sometimes a question mentions total pressure. So when they say total pressure, What does that mean? Remember that even air has pressure. So above the surface of the water, there is atmospheric pressure pressing down on the water surface and adds to the pressure acting on the objects within the liquid. So if you were asked to calculate total pressure would be the sum of the atmospheric pressure plus the liquid pressure. In case you're wondering, oh, how do we calculate atmospheric pressure? The concept of atmospheric pressure has already been removed from this cohort's syllabus. So if you were required to calculate total pressure, you don't have to calculate it. The value of the atmospheric pressure would be provided to you in the question. So the kind of question that you could come across would be to calculate the total pressure. So what you do is you just add the atmospheric pressure with liquid pressure. Just fix the H a little bit. Or they could give you the total pressure, they give you the atmospheric pressure, and maybe they want you to calculate H, for example. So then you need to calculate the liquid pressure from this formula and then take this formula to calculate H. Really depends on the question. But generally, this is what you need to know when it comes to liquid and total pressure. So that's Unit 1 in a nutshell. I hope you found this video to be educational and helpful for you to prepare for your upcoming examinations. So if you need help for a specific topic within this unit, please watch my video on that specific unit. In the meantime, happy studying and all the best for your upcoming examinations. Do like and subscribe for more physics lessons from your physics teacher, Miss Ho.